And if it ain't a hard rock, I'm not interested. You're listening to The Cosmic Cast.
Hello everyone, and welcome back to another episode of The Cosmic Cast. You're here with me. If I was a male model, I'd be the before picture, Rick Bibber here. In front of me, he looks uncannily like Dr. John Pernett Fisher, Dr. John Pernett Fisher.
Hello there.
And to my left, if me and John had a baby, that's what it looked like, Tom Harvey.
Hey.
And today the episode's a little bit different because we are doing a Q&A session. So thank you to all of you who sent in questions.
A really good haul of questions, I think. It was a lot of fun compiling these and thinking of some answers. So, yeah, good job, everyone.
And we're sorry if we didn't manage to answer your question in this session. There was quite a few of them.
So our first question is from Marissa, and she asks, who are your favourite unsung heroes of science?
Ooh, it's a good question. I don't have a specific person really in mind who'd be an unsung hero. I don't know about you guys.
No.
Do you have anyone just specifically?
Yeah, I think for me it's all the people at the coalface. It's all the lab techs that keep labs running and, all the individual, researchers, whether they be lecturers or postdocs or PhD students, they put in all the work and all the effort. They don't necessarily get the big high impact papers, but are there putting in all the breadcrumbs that all feed up to what ends up being these larger ideas, perhaps.
I think that's a very good point, because the things that are, I guess, these big papers that come out, or this science that blows people's minds, there's actually a lot of work behind it that leads up to that point, and there can be a lot of misses before there's a hit, but you need those people to make the misses before you can make the hit, essentially.
Yeah.
So,
I mean, these are stuff that, they don't get press releases. They're not reported by, the BBC or The Guardian or whatever. It doesn't help that a lot of this research is often blocked behind paywalls. I mean, this is, we've talked a bit about publications and publishing papers and stuff over the past few weeks, but perhaps something that we haven't mentioned is that, a lot of this work, they're locked behind paywalls. All these big journals require subscription fees. And if you want to buy individual articles, it costs like, 30, 40, 50 pounds. And it's outrageous. There's a lot of stipulations now that funding agencies say that you've got to make these things open access. But I mean, the whole model of publishing perhaps isn't the best in the world, I would say. And it's not necessarily the most ideal to disseminate what we all do collectively as a community to the general public.
But to answer the question, I guess the thing is everyone who is involved, even those who are lab techs, without them, we wouldn't be able to do our jobs, to get the scientific questions answered. Yeah. So,
Hope that answers your question, Marissa. So our next question is from Matthew Harvey. Thank you very much for all your questions. So to answer your first one first, I suppose, despite news/film stereotypes of individually slightly mad scientists makes earth-shattering breakthrough, many advances are made through collaboration between individuals, institutions, and often different disciplines. Can you highlight or discuss any current collaborative work in solar system geoscience that is particularly productive or novel?
So I don't necessarily know any novel ones. I know for any type of mission that's sending a robot to another planet, for instance, I worked very briefly with the ExoFit team, so the people who are testing the rover that is going to become the ExoMars, essentially, testing it on Earth. And that is a collaboration between engineers, scientists. It's just like we were saying before for the who's your unsung heroes. Everything that leads towards a big scientific goal requires people of different disciplines. Yeah. So, for instance, with that ExoFit, there were engineers on the team whose sole purpose in the team was just to know how one of the instruments runs. And, for instance, I wouldn't know how any of those instruments really runs, but I would understand what the data at the end tells me. So without them, there's no way you could actually fulfill the goal. So if we're going to send a robot to somewhere like Mars, like ExoMars in 2020, hopefully, we need all those collaborations of different people from essentially similar disciplines, but different enough that not just one person could do the job, essentially.
Yeah, I mean, this is definitely the case for mission stuff. I mean, I guess you require perhaps less people if you're just doing sort of more simple geochemistry stuff that isn't
Like
relying
yourself.
on.
Yeah.
So I mean, I don't really have that many exotic collaborations really that I can think of. I mean, the most exciting that I've done in terms of collaborative work is going to the Scripps Institute of Oceanography in California and just being by a beach for a few days. That was quite nice. But
And that was your input into that scientific project. John Burnett Fisher, the unsung hero of science.
It's a fantastic campus. It's literally right there on the seafront. It's maybe like, I don't know, 50 yards away from the beach.
Yeah.
It's you can actually see the ocean from the geochemistry labs. It's quite a remarkable place. Well, I hope that answers your question. So moving on, we've now got a little series of 3 questions that are fairly similar from Matthew Harvey and 2 from Vicky Hudspeth. So I'll just read all 3 of them out in a row, and I guess we'll discuss them in general.
Yes,
they're quite. I think they're fairly related. So Vicky asks, if you had unlimited funding, what are the big research questions you'd like to answer? And then Vicky also asks if it's possible to collect samples from any planet on the moon or in our solar system or beyond. Where would your opinion be the most interesting samples to come from? And I think this links quite nicely to what Matthew Harvey asks. If you could have a single sample of a meteorite or similar to analyse to work on, which would it be and why? If we had unlimited funding, then, let's just go for it. I would like to see things like
unlimited funding and unlimited time.
Unlimited time, just unlimited...
Everything.
I'd like to see a comprehensive geological manned survey specifically of places like the moon and Mars.
Yeah.
It's only with 2 feet on the ground and humans actively exploring planets that we can get the best out of geology and
100%.
collecting sample sets. There's only so much rovers can do.
Yeah.
And if we've got unlimited time and we can break the laws of physics, then I'd like to go to exoplanets and see what geology is like in other solar systems and in other potentially habitable planets, and to see how really unique
ours is.
So, but perhaps reining it in.
Sorry, just if you went to an exoplanet, would you expect to find basaltic rocks there?
Well,
rocks from volcanoes. Sorry,
theoretically.
Yeah. I mean, we've seen that. For instance, basalts are ubiquitous throughout the solar system.
Exactly. So why would they be different?
Why would they be different?
Exactly,
Unless the starting materials of different solar systems,
which would be interesting. Yeah.
So I mean, these are these are really sort of big picture type questions that we simply don't know, and would genuinely be very interesting
and there's a lot
know.
that you can learn from remote sensing of exoplanets.
There is, but
atmospheric.
Yeah. Well, exactly. It's not hard rocks.
Yeah.
And if it ain't a hard rock, I'm not interested.
So,
You
but
should get that tattooed.
in a more realistic sense, if we could get a sample from anywhere within our solar system, what would you really want?
Yeah, well, I think for me it would have to be somewhere like Venus.
Yeah, okay.
Venus is a planet that we know next to nearly nothing about relative to a lot of the other inner solar system planets. We don't have any samples in the meteorite collection. We've only ever landed one thing on the surface that went splat rather rapidly and melted on the surface of Venus.
So I guess why do we not have any samples, and why did it go splat is probably a good question.
Well,
to answer.
it's got an incredibly thick atmosphere that's incredibly toxic, and the pressures at the surface of Venus are huge, such that a small instrument basically just crushed itself under the weight of its atmosphere. It's a runaway greenhouse planet. So, it's and because it's going inwards towards the solar system relative to us, it's a bit more difficult to get to in terms of launching rockets and calculating orbits and all that kind of thing.
And in terms of meteorite samples, I guess anything that could theoretically leave the atmosphere of Venus rather than coming towards the Earth would just go directly towards the sun, really, because it's closer.
And actually, I guess because of how thick the atmosphere is, any large meteorite is not going to do anything much yet. So I mean, I guess this is not something I think we've talked about too much before. I mean, the reason why we have lunar meteorites and Martian meteorites are because really large impacts smacked these bodies so hard, and they were so big that material went flying into space and ended up on a trajectory to eventually land on Earth. And I think that any large meteorite on Venus would probably just get absorbed into the atmosphere, would probably burn up, and it would be really difficult to get material off the surface in the same way that have done for the moon and Mars. But not just that. So the reason why Venus specifically will be really interesting as well is because it's our sister planet. It's a similar size. So we think that it should
Similar internal structure.
Similar
as well.
internal structure, yeah. And very early on in the Earth's history, before Venus underwent all this runaway greenhouse effects, people think that it may have had actually quite a temperate atmosphere. It would have had very similar conditions to here on Earth, and so may have developed similar geology. It's big enough that plate tectonics may have started to get going in the same way they have here, and so it's I think a reasonable candidate for maybe life to have started very early on in Venus, but we don't know. None of these rocks are available at the surface for us to analyze. We don't
because
really
the
know.
atmosphere is so thick as well, we don't have direct imaging. It's all done by radar.
Radar, yeah. So there's a lot of unknown questions and a lot of potentially very interesting questions thinking about how the Earth also develops in its earliest phases could be answered.
I think another interesting sample might be one of those meteorites that's landed on Mars and has been imaged by the rovers, like the one that Alistair was talking about a couple of weeks ago.
Not listened to that podcast, I'd highly recommend listening to that. It's very interesting.
Talking about possibility of life on Mars and where you can find them.
We'll bung a link in the description for your convenience.
But for comparative purposes with Earth meteorites, it's been through a different atmosphere. It's landed on a surface with very different weathering conditions, depending on when it landed.
Yes, yeah.
So it would be fascinating to see how that's affected, whether it's affected its composition differently and what weathering conditions are like on Mars or were in the past.
Yeah, so I think if you sampled ones that were possibly landed when Mars had a thicker atmosphere and compared that to one that possibly landed in the last 100,000 years, how different do they look in terms of how they're weathered? So yeah, thank you very much for that question. It was a very, very good question.
Indeed it was.
Yeah.
So next, here's our last question from Matthew Harvey. In the last 20 years, there's been a huge increase in data, images, analyses in the solar system. What planned missions by any of the big agencies like NASA, ESA or Japan, or even private, are you most excited about? So for me, that has to be, without question of a doubt, the Psyche mission.
Yeah, definitely.
So this is a mission that is going to an iron asteroid, and this is the first time we'll ever gone to an iron asteroid. We don't really know anything about what that might look like. I mean, it raises a lot of very fundamental questions, like what does an impact structure look like on such a body, for instance?
So like if you get a crater on a giant piece of iron,
what does that look like? What does a regolith look like?
Yeah.
How do these bodies weather and erode and just
Well, and what kind of activity you might find on a large metal asteroid as well.
Exactly.
I think I've seen, I don't know how realistic this is, but I've seen schematic diagrams, artists' interpretations of what look like sort of mini metal volcanoes. I don't know whether that's actually something that could
I
happen.
don't know. But I guess in terms of visual impact, I think it has the potential to be very striking.
Yes,
and in terms of geological processes, it has the potential to be pretty novel, I think. So that's what I'm particularly excited about.
So just out of interest, so something that's just a solid piece of iron, well, not solid, but a fully iron asteroid.
Yeah.
Is that a sample from within a planetesimal then? Is that something that was going to become a planet?
So iron asteroids are fragments broken up from differentiated planetary bodies or larger asteroids.
Yeah.
So they represent the deep down core material that we can't access on Earth. And that's actually one of the reasons that we look at iron meteorites to begin with, is because they tell us about the internal structure of the planet that we can't see. I think another particularly interesting answer to that question is the expansion in private space exploration.
Yeah. I mean, the Israelis came so close recently, and if they'd actually landed properly, that would have been quite...
So they were landing on the moon.
Landing on the moon, yeah. So this is the first private attempt to land on the moon, and if they were successful, I mean, the fact they got into orbit and were in a position where they were landing is still quite a significant watershed. But if they were to have landed, that would have been a real marker, I think, in space exploration history. And it's slow steps, I guess, isn't it, in the private sector? It's slowly building up to become a force to be reckoned with.
Yeah.
And I think that it might be what's needed for NASA to stay competitive, because there's no geopolitical angle for NASA to really compete like they did in the 60s and 70s, and maybe it's going to be competition from the private sector that will drive us to go back into space in a more serious fashion.
Should be very positive indeed, yeah.
For a lot of reasons as well, because that competition drives the technological advances that actually make them improve, which has massive benefits for the rest of society.
Oh, absolutely. So I'm writing an article at the moment that's going to hopefully come out in the summer about the legacy of Apollo at 50, and I was writing a small section about some of the societal impact and some of the technological impact. And I hadn't really, before starting to research this, really appreciated how much of the everyday technology that we use stems from the developments they made in the 60s, specifically for the Apollo program. I mean,
non-stick pans, for instance.
Well, that's a myth, actually. Non-stick Teflon was actually around much before Apollo.
Well, I think it was the Bronze Age, wasn't it?
Yeah, it was the Bronze Age. Famously, they discovered Teflon. But seriously though, I mean, it's fairly mundane things like, for instance, a lot of the athletic sports shoes that people wear, all the sort of
run fast on the moon.
Yes, they run fast on the moon. Things like retractable roofs on like sports stadiums and stuff is directly linked to advances they made in spacesuit material, and just like even things like tackling fires. There was that fatal fire, wasn't there, in the earlier Apollo program that led them to develop like fire retardant fabrics and other ways of extinguishing fires. And just and even just the sheer force of being comfortable with sending things regularly to space has enabled all these satellites to now be in orbit. And without the Apollo program, it's questionable whether we would today even have very basic things like GPS navigation or all these satellites to help model weather forecasting and all these kind of things. We may not be as advanced as we are today if it hadn't been for the impact that something like a space race can produce.
I mean,
so
it goes beyond technology as well, because of all the research that's doable like at the space station, but that isn't doable on Earth. We know a lot more about the human body because of the effects that low gravity's had on astronauts and things. So
that's a really good question. Okay, so the next question is from Anne Pernay. Why, this is a very good question actually, why can't we drill the moon's surface to get the samples that we need instead of waiting for impacted samples to come up? And it's a very legitimate question, I think.
So last week we were talking about how for your anorthosites you're looking at, they were things that have been removed from underneath the surface by impact cratering. It's a very good question indeed.
And the simple answer really is that it's really difficult to drill on the surface of the moon or on other extraterrestrial bodies in general.
So when the Apollo missions went, they didn't sample anything that was necessarily what we call bedrock, did they? It was all boulders essentially.
Yeah, well, certainly for Apollo 16 anyway. But they did do some drill cores into the surface of the moon, but they didn't go down very far, only really a couple of centimeters. It's because of the low gravity environment, it's really hard to sort of dig deep and drill deep. I mean, a lot of current missions at the moment that are being planned to explore some of the polar regions are planning drills that are meters long. And I think on Mars also they want to drill meters long. But this is, it's still quite shallow, but that's a hell of a technical innovation to be able to do that. It's just really tough to access.
And there's the added challenges of the low gravity. The fact that there's a limit as to how much mass of machine you can actually send. And the fact that the sediment, the regolith that covers the surface, is in comparison to Earth's surface or Earth regolith is very different mechanically, which I think gets in the way.
I think it's something that a lot of PIs and missions, principal investigators, would like to do, but I don't think our level of technology is quite there. I mean, because in theory, it seems like it ought to be quite a simple thing to do, just bung a big drill core down there. But
we're hoping to have a chat with another PhD student here at Manchester, Gunter, who is working on. He's an engineering student. He's working on resource utilization on the moon, so he might have some more insight into the challenges of actually.
He spent a lot of time thinking about some of these problems, so we'll definitely try and get him on in the next few weeks. And
That's another excellent question. What's next?
Okay, so next we've got a question from Jess Caudron. She's a teacher, and she asked her Year 8 class if they had any questions, and they came up with this. When are we going to be able to visit Mars, and can you really grow potatoes there?
I mean, that's an amazing question, set of questions, especially from a Year 8 class.
Yeah.
So
They've definitely seen The Martian.
yeah, which is, weird because I haven't even seen the film all the way through. I often get people asking me, have you ever seen The Martian? As soon as I tell them what I do. I always feel bad when I say no.
Right. Well, I mean, the key point is that it's science fiction.
Well, I mean, most of it's dead on.
Yeah. Anyway, but genuinely though, it's when are we going to visit the moon? The Mars.
Who knows?
I mean, what was was it these Dutch people who wanted to send people? Was it Mars One or something? The competition that they were going to send all these people for a one-way trip to Mars.
Oh yeah, that was a while ago.
Yeah, that fell through pretty rapidly, didn't it?
You'd send in a video of yourself and say why you think you should be on the mission. And it wasn't what you'd expect. It wasn't people going like, well, I'm a geologist, so
no,
I'm a Martian geologist, or I'm an engineer, I'm a space engineer, and I know how to use a spacecraft. It's none of that type of stuff. It was people going like, I'm Vicky from London, and I'm a bartender, and I'm super enthusiastic about stuff, so I'll bring a great thing to the mission. And you just get 5 people who should be on Love Island out in space.
Actually on Mars.
Yeah. So in answer to the actual question, though, when are we going to get people on Mars is a tremendously difficult question to answer. So I know that SpaceX want to send their first manned mission to Mars in 2024, which is just implausible for many reasons.
If it was sending people regularly to the moon right now, then I'd say, maybe. But we can't even get back to the moon.
Yeah.
And that's much closer. So I think it's...
large difficulty lies in, so for the moon, it's not that far, as you said. It's a lot closer.
Yeah.
And you're not... So that means you're not spending 9 months traveling there in the first place. And then the other issue with Mars is that once you're on it, if you ever wanted to come back, you'd have to wait 2 years until the orbit was in the right place for you to then come back again. So essentially, we're talking about a 4-year round trip if you could do it. And we don't know if a person can survive in space that long, for starters.
No.
So it just seems implausible. Also, the other issues are radiation. So being exposed to radiation for that length of time, you are going to die, essentially. So at the moment, we're just not there. Maybe if you said 2050, I would still shrug my shoulders and say, implausible, but I
just
don't
like
know.
that.
Yeah, just like that. But I don't know, it could happen.
But what about the important question here? What about the potatoes?
So can you grow potatoes on Mars? So under current conditions, no. But in the way that Matt Damon did it, I guess he was inside.
Yeah.
He was shielded from the atmosphere, which would destroy anything on the surface.
He was just using the soil, basically, wasn't he?
Yeah. So he's using the soil and water. So yeah, you could if you could do that. But with Mars radiation, nothing can survive under the first few, probably about a centimetre underneath the surface, maybe a little bit less than that. But because of radiation, it can't. And but to honestly answer that question, what is quite intriguing about Mars is that there are these things called meandering channels on them. And meandering channels on Earth didn't form before plants were on Earth. But we find them on Mars. So the question is, why do we have meandering channels on Mars? Maybe they were potato plants there at one point that allowed you to form these meanders.
But going back to the meandering channels, though...
So the reason you'd require plants for meandering channels to form is because you need stability to the banks for them to meander. Otherwise, they form what we call braided channels. So where you've just got a load of fingers, essentially, to the channel.
Yeah.
So a meandering channel is one channel that meanders, as I said.
We're talking oxbow lakes here.
We're talking, so they can form oxbow lakes, and we found oxbow lakes on Mars as well. And so
current thinking is that you need some form.
You need something to stabilize the banks.
And on Earth,
that is
like
plants.
roots and plants.
There's the roots from plants holding things together. Yeah. So on Mars, we don't have any evidence that there were ever plants there. So the other option could be that there was loads of clay, because clay can hold things together.
Quite sticky.
Yeah. Or there was a load of ice, because ice can make things stick together as well. But at the moment, we don't know.
Interesting.
Maybe it was these potato plants these
Maybe it
kids are
was
talking
potato
about.
plants, yeah,
Yeah.
very true. Very good.
So thank you for asking the question, Year 8.
Yeah. Our next question is from Eleanor Baker. So, what books would the team recommend for people who are interested in planetary science in general but have no experience as they are but humble art students?
Well, thank you, Eleanor.
I think the first thing that tends to spring to mind for most of the information that I have is textbooks, but that's probably not the kind of thing that's very easy reading.
I would say
especially if you
that is
haven't got a lot of
diving into
context.
the proverbial deep end.
Yeah.
Yeah.
I think there are some excellent books which make a very good job of introducing the reader through kind of explaining big ideas and the context to the history of the solar system, about the solar system, the Earth system, and how processes have affected them over time. So A Short History of Nearly Everything by Bill Bryson is a fantastic.
Excellent starting point, I would say.
Recommend it to pretty much everyone. It's quite funny, which makes it easy to read and easy to digest, and it's also told partly through sort of the history of Earth and planetary sciences, and done with interviews with specialists when it comes to the kind of detail that is necessary. And it covers a bit of chemistry, it covers a bit of physics, it covers astronomy and the origin of the solar system, all the way through the early Earth to life, and it's fantastic. So that, certainly.
There's The Cosmos by Carl Sagan, which I think is another good one.
It's a very interesting read, and I felt very kind of enthusiastic and excited about science, especially.
I think something that makes learning about something easier, as we already said, was like humor, for instance, but something that interests you.
Yeah.
So I think a book like that can get you interested in a topic is a good place to start as well.
I mean, there's a lot of books about more detailed things. Simon Winchester has definitely written some excellent books about sort of quite narrow topics. A book about Krakatoa, a book about William Smith, who designed, I suppose, the first geological map of the UK. And so in that vein, there are more kind of historical books about the kind of history of the science. But Bill Bryson's Short History of Nearly Everything would be my number one.
Yeah, start there.
Yeah, so that's a really good question, because I think for a lot of people, actually getting into the kind of context of science is the hard part. The enthusiasm comes naturally to a lot of people, and so stuff like that is fantastic. So thank you for that.
Absolutely. Brilliant. Well, so finally, we have a question from Samuel Bancroft. And this is actually a really difficult question. I spent a lot of time thinking about this on the train this morning. What is the best way you would explain/demonstrate your research to a 5-year-old? Because I think, this, particularly for our specific research, like for instance, the paper that I talked about last week, it requires so much contextual knowledge to fully explain that, to then pitch at a 5-year-old level. I mean, that really is honing your skills of science communication. It's all something that I think we strive to do, but can be quite challenging.
Yeah.
Well, and I think a lot of explaining, maybe to somebody who's 5 years old, a lot of what you're trying to communicate is the kind of the importance of the science in the kind of wider context than maybe you would even consider in a paper conclusion or something. Imparting the fact that you're trying to understand, how planets in the solar system work, because you want to understand how the solar system works, because that's really the overall driving questions to all of planetary science research, really, a lot of the time. That's probably where I'd start. Then
I guess when we do our outreach events, though, when we're showing people meteorites and trying to explain that initial thing of what a meteorite even is, the thing of trying to tell a 5-year-old, because we do get kids around that age sometimes coming to the stalls and stuff, trying to even explain that this is something that has come up from outer space is a difficult thing to explain. And to try and even explain that there were things before we were here is something that is it's a hard one to grasp, really. I mean, mine's fairly easy compared to both of yours, in the sense of a child knows what a river is, or they at least understand running water, you know what I mean? Or saying, if I poured water on this surface, it would go downhill.
Yeah.
That's something they could grasp, you know, they could understand. So saying, I look at where water was on Mars, the planet Mars, and then try and understand what happened to the planet from that is a fairly easy thing to explain to someone.
Yeah.
They might not know what Mars is, but if I just said it's like the Earth and it's out in space, they might kind of grasp that idea. But trying to explain to them what a meteorite is and what it tells you about the moon, for instance.
I guess the moon is perhaps a little bit easier in the respect that you can point at
See
it
it,
in the sky and say, well, you know, these bits that I'm holding in my hand came from all the way up there, while gesticulating at the moon.
But Sam raises a good question, and it is something, as you said, we do strive to do. We do want to be able to communicate our science to
Clearly as possible.
Yeah, it's clearly possible to any generation. You know, be it 5-year-olds or be it 18-year-olds. You know, we want to be able to explain it to the public.
Yeah.
So yeah, no, it's a very good question indeed, and unfortunately, I don't 100% know how to answer it.
Yeah.
But you've got us thinking, which is obviously what you wanted to do. So good on you.
Great. Well, thank you all very much for everyone who submitted their questions. There was an excellent haul there, and definitely got our thinking caps on. And we'll try and do one of these again at some point. In the future,
if you enjoy it and if you like the format, then let us know.
Yeah, please do like or submit comments.
Yeah.
So we know what you like and what you don't like. That's
right. I mean, if you've got any burning questions, you know, you want us to answer in general, do comment on the video below, and you know, we'll maybe try and squeeze some answers into podcasts in general.
100%. Yeah, I think we're going to start going back to the guests soon, though. I think in the next few episodes, we're probably going to have some guests.
Yep.
But just comment when you can, and we'll do another Q&A if we get enough questions coming in. I guess.
Yeah. Well, thank you all very much for listening, and we'll catch you next week.